Gravitational force is a force strong enough to hold our universe in place. It holds the Earth in orbit around the Sun and the Moon around the Earth. So, should this strong gravitational force not also pull us towards the very center of the planet? Should we not all plummet to our immediate deaths? And yet, somehow we don't. The ground beneath our feet holds us in place, and it is the electromagnetic interaction between the atoms, an interaction far stronger than gravity, that keeps us, human beings, together. So, how and why does this force behave so? To understand the electromagnetic force, we can talk about the electric and magnetic forces and how they interact. The electric force is the attraction between positively and negatively charged particles. In essence, between protons, a positive charge, and electrons, a negative one. The atoms that make up matter around us are a collection of such charges, with the protons residing in what is called the nucleus and the electrons orbiting around them. The magnetic force can most simply be described as a charge in motion, which creates what is called a magnetic field. Two objects containing a charge in the same direction experience attraction, while objects with charges moving in opposite directions experience repulsions. So, in essence, a moving electric current can create a magnetic field around a metal, and in turn, a magnetized metal can induce current through relative motion. These two phenomena combined make up what we call the electromagnetic force. Another feature of this force is what can be called action at a distance. It means that the protons and electrons in an atom are not stuck together, but rather they can interact no matter how far apart they are. But how can two particles test one another over an infinite span of space? They emit particles of light to one another, particles known as photons. A simple analogy would be this. Imagine us two, standing in opposite corners of a room, passing balls to and from one another. We are not next to each other, we may not even be able to see one another, but as long as we receive balls from a particular direction, we can know of each other's existence. And as photons are the carriers of this force, the larger the distance they have to travel to reach another particle, the weaker the interaction becomes. So the strength of the attraction decreases as the distance increases. Stated mathematically, the force is inversely proportional to the distance squared, relationship exemplified by the following graph. Theoretically, the electromagnetic force can act over an infinite distance, but practically this attraction is negligible on a cosmic scale. So, if the gravitational force governs the celestial bodies, the electromagnetic force is the one that governs what is immediately surrounding us, humans. It is not only what holds together the ground beneath our feet, but also explains everything from how we produce energy for our muscles to how we charge our phones. In essence, there is more empty space between our nuclei and our electrons than the total surface area of all existing particles, making us and the rest of the world at large empty space. So, can we claim that we can ever truly touch anything? And, even more mind-blowingly than that, the electromagnetic forces pass through photons, so are we not beings bound by light?